Hello class and welcome to lesson 5.5, solving problems involving polynomial functions. What we're going to do today is use our knowledge of polynomial functions, graphing, substituting, and solving equations to problem solve. Remember that A, min and max values occur at the local min or max. Okay. B, initial value occurs at the constant. C, substitute in the independent value into the equation in function notation to find the dependent value. And don't forget to include concluding statements for all application questions. All right, let's take a look at the first example here. Example 1. In an electrical current, the voltage V in volts as a function of time, which is T in minutes, is given by this formula. Okay. All right, what kind of function is it? Well, first of all, you look at the highest degree, and it's 3, so that tells us it is cubic. So this is a cubic function because degree of 3. Oopsie. See if I can spell. All right, what is the voltage after 5 minutes? So we're going to sub in T equals 5. Okay, so instead of V at T, we're going to go V at 5. They just didn't put that down. I'm just changing it to function notation. Equals 2 times 5 cubed minus 9 times 5 squared plus 12. Do some calculations here. You're going to get 5 cubed is 125 times 2 is 250. Subtract 5 squared is 25 times negative 9 is negative 225. And again, just plug it in your calculator, folks, okay? And to simplify this, you should end up with 37. So therefore, it has a voltage of 37 volts. Don't forget your units there. Okay, and that you could say after 5 minutes if you want. Okay. All right, C part. Use technology to determine the time when the voltage is a value of 257. So 257 is an important thing to do. So I'm going to pop up my graphing calculator, guys. I'm going to have already had my equation in. So if not, you just go to y equals, type in your equation. Instead of using t, I just have to use my x variable. So I have my equation, which I can then show you as a graph. Okay? So two ways to find out when the voltage is at 257 is I can go to my table first. So go to second table, and I'm going to go all the way until I can see the answer, which we're looking for is 257. So I've got that. Let me just quickly capture that. And bring it in. Okay, so there's one thing I did. So using the table. So T of V, could find it after putting the equation in. Or, ladies and gentlemen, do you remember the other method from last class? If I have my graph, I've got the one equation already. I'm going to put my linear line in, which is 257. And I'm going to graph both of them, and then I'm going to find the point of intersection. So to do this, I go second trace, find the intersect, which is 5. Cursor's on one, hit enter, make sure it's blanket on the other, hit enter, guess, hit enter, and there you have it again. And that's something I will capture and bring in. So you can choose which method again. Okay. So depending on what you want, this is the point of intersection on graph. Okay, and again, for those who remember, you press second trace, which is your calculate menu, and then press 5, enter, enter, and you're going to get those steps there. All right, so don't forget, because this is a word problem, we don't just leave it as x equals 7. We're going to say, therefore, the time is 7 minutes to get a voltage of 257 volts. Good. So remember to relate it back to the word problem. Okay, let's take a look at another example. Okay, example number 2. Okay, Murray's playing baseball and he hits a pop fly. The baseball's height, h in meters above the ground in t seconds after being hit, is given by this function right here. Okay. Notice, ladies and gentlemen, this should be most familiar to you. This is quadratic. Okay. How do we know it's quadratic? Because it's ax squared plus bx plus c. Okay. So it says, question A, which finite differences are constant? Well, we already talked about it being quadratic, and hopefully you remember that with quadratic, second differences are the same. Okay. And you could also take a look at the highest degree, okay, which would tell you that the second differences are going to be constant, okay, because of degree 2. You could say of or is 2. It doesn't really matter to me. All right, describe the end behavior for this function. Well, first of all, you remember with quadratics, you're dealing with parabolas. Okay, look at our characteristic of our parabola. Is it opening up or down? Well, first of all, you notice that if I write down here, guys, looking at A equals -1. It's negative, so that tells us it's opening upside down. So to talk about our end behaviors, if I start with the first end behavior, so as x approaches -infinity, what's happening to y? Y is also approaching -infinity. Okay? And I look at the other end behavior, as x approaches positive infinity, y is also approaching -infinity. Okay? Good. How high was the ball when Murray hit it? So when Murray hit it, remember our time is 0, so t equals 0, so you could sub that in, or you could look for what we call the y-intercept, okay? So you could just look for the constant, okay? So the constant would be just 1, so therefore Murray hit ball at 1 meter. Just remember, look at constant for your y-intercept, okay? All right, next one. How high was the ball after 3 seconds? So you sub that into the equation. Instead of t, you're going to let t equal 3. So it's going to be h at 3 equals -3 squared, I'm just subbing it in, plus 10 times 3 plus 1. Do your calculations, so you should have -9 plus 30 plus 1. Plug in your calculator or do mental math, and then you can say, therefore, it was 22 meters after 3 seconds. All right, keep moving on here. When was the ball's height at 25 meters? What do you have to represent that? The height. So that means h at t actually equals 25. Guys, I'm just going to write that a little cleaner because it's sloppy there. So we know h at t equals 25 meters. Okay, so what we're trying to find is when. That tells me we need to find t equals question mark. Okay? So if we know our original equation is h at t equals negative t squared plus 10t plus 1, we can sub that value in here. So we've got 25 equals negative t squared plus 10t plus 1. Now to solve this, we need to get the 0 on one side. So I'm going to put 0 on the left. I'm going to bring the 25 over and change the sign. So I'm going to have negative t squared. I'm going to have plus 10t, and when you bring that over, you're going to have negative 24. Now, noticing things are negative here, it's going to be easier to make everything positive by changing the signs. So make everything positive, or times everything by negative 1. Okay, so times by negative 1. So 0 times negative 1 is 0. Negative 1 makes that positive, makes this negative, and this positive. So whatever you do to one term, you can do the same to all the terms, and it'll stay balanced. Notice this, ladies and gentlemen, in order to solve, we need to get zero product property happening. So we need to take this and actually factor it out. Okay, so let's remember some of our factoring skills. What do we know? We know the product equals 24. We know the sum equals negative 10. What two numbers multiply to 24 and sum to negative 10? Well, first of all, negative times a negative gives you a positive, so you know they both have to be negative. And what two numbers are that? 6 and 4. So you should remember how to do this, where you go t minus 6 and t minus 4. Okay. And finding the actual answer, because the left side has to equal the right side, so how do we get the right side to equal 0? You let each bracket equal 0, so t minus 6 equals 0. Solve for t equals 6. Likewise, the other bracket could equal 0, so make that equal to 0, so t equals 4. Okay? So the question answers, therefore, the ball is at 25 meters at 6 seconds. We should probably do an order at 4 seconds and 6 seconds. Okay, so that answers the first part. The second part, why are there two answers? Well, when you think about a ball being hit, it's probably hit at 1 meter, as we said. We know it's got to come up and then come back down. If I use my technology and say, hey, I know the height is 25, so it's going to be 25 meters, so it's going to hit at 4 seconds and at 6 seconds, which means hopefully, guys, it reaches its maximum height at how high? At 5 seconds it's at its maximum height, because it's quadratics, right? Remember, these are symmetrical points. Okay, so we have to say that there are two intersection points. Intersection points, because quadratic. Has sim points. Relating it to math, you could say because the ball on the way up in the air hits 25 meters, goes higher, and then it hits it on the way back down. All right? Here we go, ladies and gentlemen. Here's our homework, page 29 and 100, numbers 1, 4, 5, 7, 10, and 12, and have a fabulous day.